Hey, thanks for tuning in. My name's Jonathan Clark. I'm also known online as DJ Bolivia, and in today's video I'm going to try to explain what a DI box is and what it does. And one quick note before we get started: if you're looking for other videos about DJing tutorials, music production, audio recording, technology, anything really associated with music in those respects, I've got a whole lot of other videos. You can find them all, nice organized list, at djbolivia.ca/videos. So if you want to go to that page, bookmark it. You might find some other stuff that's useful too. Anyway, let's get right into the today's video, and that's about DI boxes. So if you're a musician going to a performance, you may have the stage engineer, stage manager, an audio engineer tell you that you need to be using a DI box for some reason. Okay? And a DI box, they may call it by other names too. They may call it a direct box. They may call it a direct injection box, DI. They may call it a direct insertion box. But all four of those terms mean the same thing, something like one of these. Okay, so why would you need a DI box? Well, the simple answer is there's three main reasons, and the first two of those reasons are by far the most common reason why you'd use one, but sometimes there's a third reason. Okay, so the first reason is if you're trying to send a signal over a long distance, you may use a DI. And an example is, let's say that you're playing guitar on stage, the soundboard's way out in the audience, and most guitar patch cords are pretty short, like 10, 12, 15 feet. And so that's not long enough to reach. So you could plug into the DI box and then send a cable out of the DI box for a long distance. So that's the first and probably the main reason for a DI box, sending signals over a longer distance than usual. Second reason is to eliminate noise that's coming through your cables. And so you might have what's called a ground hum or a ground loop. And basically it's when there's an electrical problem in the system, and so you're getting noise coming through your cabling. And so a DI box can eliminate that. Okay, so that's also a common use of a DI. And then finally, the use that's not as common is when you're dealing with an instrument or device and you need output impedance matching. And so we'll cover that later. But that's not nearly as common a use. Okay, so if a DI box basically processes signals, then obviously it must have an input side to get the signal into it and an output side to send off this processed signal somewhere else. Okay, so as an example, on this one of these two is an input, ignore the other one for now, and then on the other side you have an output. Same thing with this. This is an input, you can ignore this other one, and on the other side we have an output. Okay? So let's look at the input side first. Now, there's different types of cables. This is what I normally call a patch cord, or a guitar patch cord. And that's probably not the best name for it, but it's one that many people use. Now this cord on the end has what's known as a 1/4 inch plug. And that's a problem because some people will call this a 1/4 inch cord. And that's not really an accurate way of describing the cord. There's different types of cords. For example, there's balanced or unbalanced cords or cables. The plug type, 1/4 inch, which by the way refers to the width of the plug. So 1/4 inch really refers to a plug type, not a cable type, okay? So that's something that you'll find any proper studio engineer, audio engineer, or technician will probably cringe a little bit if you call this a 1/4 inch cord. So what they would like to see is the cable described plus the plug type. So this cable happens to be an unbalanced cable. So a good way to describe this properly would be unbalanced cable with 1/4 inch mono plug. Okay? Now, to be honest, if you say it's an unbalanced cable, any studio engineer is going to assume that it's a mono plug, okay? So, you know, maybe you want to just call this unbalanced 1/4 inch cable. That will get the message across, and it's way better than saying a 1/4 inch cord. Now, how do you know this is mono? Looking at this 1/4 inch plug, you can see that there's one black band near the end of the plug, okay? This plug type, a mono plug, is also sometimes known as a 2-pin plug, okay? And so it has 2 signal paths. One is through the tip, and the other is through the sleeve. So tip and sleeve. And some people call this the sheath or the shield, but they all start with S. And so not only can this be called a 2-pin or a tip sleeve, sometimes people just abbreviate it by its initials, TS. So this is a TS plug. Okay, now is it possible to have one of these in stereo? Absolutely. Now they're not nearly as common in terms of instrument connections, but here's an example. End of my headphones. Okay, and obviously this cord needs to be in stereo going to headphones because you have 2 channels. The guitar patch cord, you know, it's probably coming out of an electric guitar, and so the signal from the pickups on the electric guitar is going out to an amp. That's only one sound source, the pickups, okay? So you only need a mono signal from an electric guitar. Same thing if it's an acoustic guitar and there's a pickup inside the bridge or something, it's mono signal. Most instruments like that, mono. And we'll cover this more later in the video. Anyway, back to the stereo 1/4 inch plug. It has 2 black bands, so it's similar to the one we saw before, but there's 2 bands instead of 1. And for this one, again, the end is called the tip. The thick part down here at the bottom is the sleeve. There's this middle part, this short band, it's called the ring, okay? And so this can be called a tip ring sleeve plug, or it can be called a 3-pin, because there's 3 signal paths, or it can be abbreviated by its initials, TRS, tip ring sleeve. Okay, so we have TS and TRS. Those are the 2 main types of cords. Most of the time, it'll be a tip sleeve plug that you're dealing with in terms of things like guitar patch cords or a patch cord for a bass or something like that. Okay, as far as the DI box goes, normally they have 1 input and 1 output, but you can have a dual channel box or a 2-channel DI, and if that's the case, it might have inputs. Let's pretend this is 2 separate cords. Let's say you've got 2 different guitars being plugged in, so it would probably have 2 inputs on one side, and then on the other side it would have 2 outputs. So it's sending 2 signals, processing and sending 2 separate signals. So moving to the output side of the DI, you will see an XLR connector. And this one is a male connector, is what it's called. Same type that you would see on a microphone, male XLR. Now, let's look at an XLR cord. This is an XLR cord. Again, not a term an audio engineer prefers to hear. They would like a better description. But anyway, XLR ends on either end of this cable, and you can see 3 pins on the male side, 3 receptacles on the female side. So this is a bit different than my patch cord where both ends are exactly the same. These are sort of mirror opposites or matching pair or something like that. So you can, if you want, take the male side and insert it into the female side, and they actually connect together properly. And it's got this little latch, so you can't pull them apart very easily. Okay, so an XLR cord can connect into itself or to another XLR cord. Okay, now, so it's a 3-pin, and you know that when I talked about 1/4 inch, the 3-pin went with a stereo plug. So will this carry stereo? Yes, it will, if it's wired that way. It doesn't usually happen that way though. Normally, this XLR cable, to use the bad name, normally this is wired so it will carry a mono signal only, and the extra pin, the extra line within the cable, is used to do what's called balancing the cable, okay? So you can have balanced cables and unbalanced cables, and one is better than the other usually. So which one's better? Balanced. Balanced is usually better. And if you want a good way to remember this, let's pretend you're walking on a tightrope very high above the ground and you don't want to fall. Balance is good. Being unbalanced could lead to problems. Okay? So if this is wired for stereo, 3-pin, then it must be an unbalanced. So that's not as good. If this is wired as mono, then it's wired as a balanced cable, which is better. Okay? So can you carry stereo over a cable with XLR ends? Yes. There's that way that I just explained. There's actually 3 ways to do it. Okay? First of all is to wire this as a stereo unbalanced. That's not a great option. A better option, number 2, is that you can get cables with XLR ends that have 5 pins, and so it becomes stereo and balanced. But those aren't as common, okay? And we're not going to use those in these examples today with DI boxes. What's the third way? Third way is the simple way. Use 2 of them, okay? So each mono cable gives you 1/2 of your stereo cable. That's by far the best way. Okay, yeah. So basically this is the output side of the DI box. This is the output side of a microphone. This is the output side of another DI box. And it's all the same thing, okay? Now, when I talked about calling this an XLR cord, again, really what you should do is describe the cable. So let's assume that these are not wired for stereo. So we're going to call this a balanced cable with an XLR end. And if you really want to seriously impress an audio tech or an audio engineer, stage manager, if you're doing some sort of sound setup or whatever, if you're referring to one of these, call it a balanced 3-pin XLR. That's definitely going to impress someone. Okay, so after that, let's look at the different types of ways that instruments can connect to soundboards. Okay, so I mentioned guitars. Guitars, multiple pickups, but they will be sending out a mono signal. Bass guitar, same thing, sends out a mono signal. What's left? Piano. Okay, so with pianos, I use 2 different terms. I call them pianos or keyboards. And technically a piano has a keyboard. But when I say piano, I'm generally referring to an acoustic piano, so either an upright or a baby grand or something like that, where the sound comes out of the piano by hammers inside the piano striking on differently tuned strings. With a keyboard, I'm usually referring, if I'm talking about a piano keyboard as opposed to a computer keyboard, I'm generally talking about something that is electric. And so the sound is not produced by a hammer striking a string, it's produced by signal being processed through oscilloscopes, oscillators, stuff like that, and creating a sound digitally that gets sent out. Okay, so it doesn't matter if you're recording a piano or a keyboard, these are generally thought of as stereo instruments. And you might wonder, why would it be called a stereo instrument? If you've got a piano sitting on stage and you're way out in an audience and you're listening to that piano, you're basically hearing all the sound coming at you from one direction. So that's basically a mono source coming to your ears. Okay? However, if you're sitting at a real piano then those strings inside the piano are spread out across 4 or 5 feet. And so some of them are sort of on your right side, some of them are on your left side. And because of that, you sort of get a stereo field of noise, sound hitting your ears. Okay, so if you're playing a real piano, it basically is a stereo sound to you. Same thing in music. A lot of times what people will do, music producers or recording engineers, they will record the piano with either 2 microphones or 2 chords from an electric piano. And when they put it in the music, they'll have it panned to the left and right, to either side. And that way, as you're listening to a song in, say, a set of stereo headphones or on a set of stereo speakers, whatever, if you're listening to a stereo song, music, then that piano will also sound stereo within the music. Okay? So, yeah, acoustic piano, they'll often put a microphone at each end of the piano. So the stuff on the right would be the right microphone would be the right side of the piano if you're playing it, which is the upper frequencies, the trebles, and then the left microphone in the music and in the piano would match more of the sound from the left end of the piano, the low end of the piano, the bass frequencies. Same thing on electric piano. If you've got 2 different mono signals coming out, it'll be labeled as left and right. The left signal will be more of the low end, the bass, lower notes of the piano, and the right chord will be more of the upper chords, upper notes. Okay, and the reason why this is important is with the piano, you have 2 outputs, and what you'll do is use 2 of your signal chords to get 2 separate signals, your left and right, into your sound console or mixer. And so that piano is considered to be a stereo instrument. Now, there may be times when you don't treat the piano as a stereo instrument. You know, different reasons. Maybe you're playing a concert and the soundboard only has a limited number of inputs. You don't have a whole lot of choices. Maybe you've got a single guitarist, a second, and the guitarist is singing. You've got a second person who's sitting there also singing, not playing any instrument, and then you've got somebody over to this side playing the piano. So you have 2 vocalists, 1 guitar, 1 piano, 5 signals. Okay, 1 from the guitar, 1 each from the 2 vocalists, 2 from the piano. But what if you've got a 4-channel board? Okay, you need to somehow get rid of a channel. So the simple solution is to just go mono out of the piano, and so that saves you a signal chord, saves you an input. There may be other reasons. Maybe there's just not enough chords around or something like that. Okay, so anyway, because of this, sometimes, yes, a piano gets brought to the board in mono. Now, usually to help with this, now, if you're working with a real piano, the solution would be to put a single microphone in it instead of 1 at each end. If you're working with electronic piano, usually manufacturers will set one of the 2 inputs and call it mono. And it's kind of odd that they would do this on the surface, because really each of them is mono. So why would they label one and not the other? Well, the reason is because the one that is labeled as mono is usually a summed mono signal. So what they do is they process the signal from the right and the left inside the piano and combine it. And if the piano detects that there is only one thing, one chord, plugged into the mono side of your pair, then it says, okay, they've only got one chord in there, they only want a mono signal, and so it sends a summed mono out through that, which covers basically half of the left side and half of the right. So that way your mono signal from the piano covers the whole thing. And most piano manufacturers, when they do this, they use the left side as mono. So if you're not sure which it is, guess mono. Guess left first for mono. Now, what happens if you put it in the right side? Does it do the same thing? No. usually the manufacturers only sum the mono to one of the two signals. So, and that's usually left. So what'll happen is on a piano like that, or keyboard like that, if you plug a single mono line into the right channel, all that comes out of it is your right signal. So you're still going to get a signal, and you'll still hear most of the music, but the problem is coming out of the right side, it's just picking up the processing from what's the right side, which is typically strong for treble, weak for bass. So if you go out of the right side, you're probably not going to get that much bass. Now, or if you're in one of those odd pianos, which is a lot more rare, where the right side is the summed mono output, then by using the left side, you're going to get a really bass heavy signal with not a ton of treble. Okay, so why would you even want to use the wrong one instead of the summed? Sometimes when the manufacturer is summing them, you'll end up having phasing issues, phase cancellation issues, and so sometimes it just doesn't sound good with a summed mono. So in that case, you might want to try the opposite solo channel and see if that does happen to give you a better sound. It may not, quite often, because you're losing certain frequencies, usually the low frequencies. But it's definitely worthwhile to check the two of those, okay? So normally, yeah, your instruments, your guitars and basses will be a single mono cable taking the sound to your soundboard, and the piano will normally be stereo through two different mono cords, okay? So the way that most microphones get their signal out to a mixing board is by sending it through a balanced 3-pin XLR cable, okay? And because microphones generally send their signal out through this XLR type of cable, they generally do not need DI boxes, okay? So I'm going to be off on a tangent here for a minute. Basically, microphone, no need for a DI usually. But let's talk again about the difference between a mono source and a stereo source. So the acoustic guitar with an acoustic pickup inside the bridge, acoustic electric, that's a mono source. A bass guitar, direct plug-in, or an electric guitar, direct plug-in, recording signal coming off the pickups in the instrument, that's a mono source. A lav mic attached to the outside of your acoustic guitar, single source, point source, so that's mono. These are all, they're called point sources because a single point of origin of the sound getting into the microphone. What else? You could have a condenser mic on a stand in front of an acoustic guitarist. That's a point source, mono. You can have a dynamic mic set up in front of a guitar amp, and that's sending signal to board. Again, point source, so that's mono. And you can have a vocalist singing into a microphone. Point source, mono. So if all these things are mono, why would you ever have a stereo recording? Why would not just go with a mono recording? Well, some of these things can get recorded in stereo. Some become stereo when they're being edited and processed. So, for example, I could, if I wanted to, with an acoustic guitarist, I could set up two microphones, each with a mono signal, same way that we would set two up inside a piano, one on either side of the guitarist, and those two signals get sent to the board, giving you a stereo guitar signal. Each side is going to be pretty similar, but slightly different. I could also simulate a stereo signal by miking the guitarist with a single mono mic and then splitting that signal into the left and right side. But that's not really a stereo signal, it's a split mono because both sides are exactly the same if you do that. And I should point out too, I mentioned earlier with the piano, and also with some of these examples coming up, if you have two separate mono lines going to your mixer, when they go into the mixer, instead of having them panned center, like you would for a normal mono line, you're going to want to pan one of them all the way left and one of them all the way right to create the effect of the stereo signal. So Yeah, I mean, with a guitar, if you record it in mono, split the signal, then you're not really any further ahead. It's not a true stereo signal. But if you're applying processing to it, and you're processing one side differently than the other, like delays or reverbs or something, then they will end up sounding differently, in which case that mono split has become a sort of a true stereo signal. And same thing happens with vocalists. You know, a lot of times the microphone, they're recorded in mono, but when you see it being edited inside a DAW, inside your audio editing software, then you might see a stereo channel there for the vocals, and that's because maybe the two sides are being processed slightly differently. Like maybe the left side has a tap delay, you know, quarter note delay, and maybe the right side has a dotted eighth delay. So they're getting different delay signals, they're getting slightly different reverb on each side, so it'll sound like, you know, something's going on differently in each side of the stereo field. So that's pretty cool. Other examples of things that actually would be recorded in stereo, let's say you have a choir. Instead of a vocalist, a single point source of sound, one vocalist voice, you've got a whole bunch of different voices. So you can put a microphone on either side of the choir, and the left and the right, the two mono signals, become a stereo choir sound. Another example is a drum kit. Drum kit's interesting because all the individual drums are usually each mic'd. And so each of those is a point source capturing mostly sound from one drum that it's closest to, and a bit of sound from other drums that's bleeding in. And then usually there are two separate overhead mics. Each of these is mono, but because they're spread out over the kit, it kind of gives the feeling of a stereo signal once they're both sent in, and one on the left and one on the right. And the neat thing is with a drum kit, all those different mono point source mics, they're usually panned to different points in the stereo field. So even though a drum kit is being mic'd in just a whole bunch of individual mono signals, because they're coming at you from different points in the mix when you're listening to the music, it gives you a stereo feel to the whole drum kit, okay? So those are the types of things. Well, I guess you'd record something in stereo. Sometimes, you know, either side of an acoustic guitarist, either side of a big choir, panning a drum kit, that sort of stuff. So different options. But remember, the single microphone is a mono source, and DI boxes process mono signals. They may process two of them at the same time, but they will process a mono signal. Okay? So let's also remember that when we're getting any of our signal, whether it's from guitar, piano, drum, vocalist, whatever, when we're getting it to the mixer, let's just consider that a signal coming to the mixer on a balanced XLR line is good. Okay, so that's our goal. And because things like the guitars and stuff do not output that type of signal, the signal coming out of them is coming through one of these, then you can use your DI box to convert to send the signal out further to the mixer on your balanced XLR cord. With the microphones, they're already sending out that balanced XLR cord signal going to the mixer, and that's why the microphones don't get used with a DI box. So why is it that it's better to have your signals coming to the mixing board on balanced XLR cable? Well, basically, balanced cable is also known as low impedance cable, and this is written out as low Z. So that's low, capital Z, capital Z, whatever you use. Okay, so if this is low impedance or low Z, this type, an unbalanced cable, is known as high impedance or high Z. Okay, so low Z is better. And basically, impedance is like resistance. So if you have a low impedance cable, there's not a lot of stuff impeding the flow of the signal through the cable. There's not a lot resisting the flow of signal through the cable. Okay, so because of this, low impedance cords, cables, are better. So basically, there's two reasons for that. First of all, because there's less resistance or impedance, the signal is cleaner, sounds better. And then, of course, related to that, because you have a cleaner signal, it means you can run your signal for a much longer distance before it starts to degrade too much that it's not a useful, good signal anymore. Okay, so that's the reasons why this is good. Less resistance. Now, in these cables, our unbalanced cable, I call this a 2-pin connection. Basically, there's 2 wires inside this cable, inside unbalanced. So one is the hot wire, one is the ground wire. Inside my balanced cable, 3-pin, 3 wires. So we have a positive and a negative and a ground wire going in a balanced cable. All right. Now, most of what I've talked about so far is basically nothing that seems obviously to do with direct boxes. Cover lots of cable connections, cable types, plug connection types, signal types, stuff like that. Well, the reason is because you need to understand all of that stuff to really understand how a DI box works, okay? And basically, the summary of what I've done so far is that balanced signals going to your mixing console on a balanced cord cable are better. And so the direct box, its primary purpose is to take a signal on an unbalanced cord and convert it into a signal that can go out to the mixer on a balanced cord. And your mixer may be pretty far away. Like I said earlier, it might be out in the middle of an audience if you're playing on a stage at a festival or something like that. And so the distance could be pretty far. Now with unbalanced cords, with patch cords, you don't generally want to have a very long cord. I would recommend you never use a patch cord longer than, say, 6 meters or about 20 feet because you're just going to get a terrible signal. And in fact, I would prefer to see you using a 3-meter cord or a 10-foot cord or even shorter. Audio engineers will want, if I was an audio engineer, I'd say the shortest possible cord is the best cord. But speaking as a guitarist, I also know that you need a little bit of freedom to walk around on stage sometimes. So there's a bit of a trade-off. But generally, yes, unbalanced signals, patch cords, stuff like that, as short as possible, 10 to 20 feet. Okay. On the other hand, your balanced signal going over this XLR cord, it can run huge distances. Like I'm talking hundreds of meters. It is not unheard of to have a signal going out to a console that's 500 feet away by using cords like this. And that's why you'll see that some XLR cords come in lengths of up to 100 feet, whereas these are rarely 20 feet even. And 100 feet, well, I just said 500 feet to a console. Well, you don't get a single XLR cord that often, which is that long, but it's okay because these connectors allow you to daisy chain them. So you can take 5 identical 100-foot cords, hook them all together end to end, and then you can go just tremendously long distance. Okay? And even if you're in a studio, say that your control booth in your studio and your where the artist is performing, an isolation booth or something like that, say they're only 15 feet apart, you probably could run your signal from the guitarist to the mixing console with just a normal patch cord. But even in a studio setting, chances are your mixing engineer is probably going to prefer that you go into a direct box right beside the guitar and bring the signal into the console in a balanced cord. In fact, in some studios, the high-end ones, it's quite likely that you might have a console that does not even accept this type of a connection. It will only be XLR balanced coming in. So let's take a close look finally at some DI boxes. Now I've said that most DIs process a signal from a 1/4-inch cord unbalanced at one end, sending it out over XLR balanced from the other end. Okay, and so basically most DIs will process a mono signal. Now some of them effectively process a stereo signal, but I don't want to call that a stereo DI. I prefer to call it a two-channel or a dual channel DI. Because what it is instead of processing a single stereo channel, it's processing two mono channels at the same time. So a good example of when that might be convenient is if you're using the DI to convert the signal from the piano to send it to the mixing board. Okay, so it's got the left and right. You send the two of them into the DI, into a single DI, then you've got your two outputs converted going out. It is also possible you do not have to have both things coming from the same instrument. For example, if you've got a two-channel DI and you want to do the bass and a guitarist through the same DI box, you can totally do that, okay? So the only reason really to have a two-channel, dual channel, instead of two individual single-channel DIs is convenience, less gear. Also, it saves a little bit of money because generally a dual-channel DI does not cost twice as much as two individual single-channel DIs. So you can save a little bit of money there. And like I said, have less gear kicking around. Okay, so what else? Okay, a lot of DIs will have an attenuation button on it, or it might be called a pad button. And the reason for this is a lot of signals coming out of instruments come out at what's called line out signal strength, and this is generally a lot stronger than the signal coming out of a microphone. So it could be 10 decibels stronger, it could be 15, 20, sometimes even 30 or 40 decibels stronger coming out of a guitar or a bass compared to a microphone. So if that's the case, when you press your attenuation pad, attenuation switch or pad switch, when you press that, it reduces the signal somewhat as it passes through the DI, and so the signal going to your board is not going to be so hot. So if you've got a really hot signal coming into your board, strong signal coming into your board, and you have to really put the trim knob or gain knob way down to accommodate that signal, one option is you can press your attenuation, and then you can work with your gain switch on your channel strip probably as at a more normal level. Okay, a third thing that you can find on most of these boxes is an input through. Okay, and the reason for that is that's going to take a normal unbalanced chord, just like what's coming in. So basically what happens is you've got a signal coming in from a guitar or something like that, and then you would have the input through used to send a signal back out that is not changed. It's not going out your balance line. And it's basically kind of splitting the signal. Okay, so one goes in and two go out. One of them going out is your process signal going to your mixer. But what if your guitarist is up on stage performing and he or she doesn't just want to hear the signal that goes all the way out to the board and then comes through the speakers? What if he or she wants to have a guitar amp set up on stage right beside them? So instead of going to the guitar amp, well, then you don't have your signal going to the board, unless I guess you mic your amp and send a signal out that way. But instead, you send your signal into the DI box, your through comes back to your guitar amp right beside you, and then your process signal goes out to your mixing console. And you do have to remember that what's coming out of your through is coming out on another unbalanced chord, so short distance. You don't want to have that amp 30 feet away. You want to have that amp and the guitarist as close to your DI box as possible. Okay, and sometimes it's called a link output instead of a through. Okay, another thing that you'll find on almost all DI boxes, because one of the reasons is to eliminate ground hum, is you will find a switch that either says ground lift or ground on off. Okay, and so basically what happens if you're getting hum or noise, ground noise, through your system when you've got everything hooked up, take your ground lift switch and put it in the opposite position of whatever it's currently in. And that should eliminate the noise, okay? And depending on the electrical system where you are, your ground noise coming through to the mixing board is probably at one of two frequencies, either 50 hertz or 60 hertz, which matches the frequency of the local electrical system. Okay, there is one other way to eliminate ground noise, and that is if you take a cable, your plug, whatever instrument or whatever is causing the problem, if you take the grounding plug right off the cable, you can eliminate it that way. I do not recommend this. Do not do this. It's dangerous. There's a possibility if there's a short, it can damage the equipment, or even worse, it can injure somebody. And in extreme cases, it can be really serious. Like, you look up online an old British band called Stone the Crows, early 70s, and one of their musicians was actually killed on stage during a performance in front of everyone by improperly grounded equipment, okay? So do not take the grounding prongs off of your power cords. And the only reason I even did that in front of you on a video is because this is a bad cable anyway. I just picked it up out of the garbage. I promise you this will never be used, so don't do it. So those are some of the features found on basic DIs. Now, if you're going to spend a little bit more money, you may get a DI that has a few extra features not found on the basic ones. Okay, so some of the things that you may find a switch labeled either REV or INV or phase or 180. And so if you press this, basically it just reverses the phase of the signal. Okay, another thing that you might get is you may get one that says filter or low cut. And basically what this does is, if you understand how filtering and EQs work, is it basically filters out, so it's a low cut, a filter that gets rid of some of the very lowest frequencies in your signal. And that's good because a lot of them are more like rumbly and stuff like that. If you've got a guitar, your strings themselves are not going to be affected by this low stuff, but sometimes, you know, bumping against the guitar or whatever, thumping, you get some really low-end rumble, especially if you're using a lav mic or something like that. It can happen. Well, it can happen with a lot of pickups too. Anyway, so low cut is good because it eliminates some of those lowest frequencies. You may also get an indicator light that shows you when phantom power is on. More on phantom power in a few minutes. You could also very occasionally get a DI that has an XLR connection on the input side. And most musicians won't use this, but sometimes that's a useful thing for a studio engineer to have because let's say you're connecting a mixer into your DI and then sending that signal out. In that case, maybe the XLR is the best way to get the signal from your mixer into the DI before you pass it on. So now let's look at the last major characteristic of DI boxes, and that's whether or not it's an active or a passive DI. And an active DI means it has an active circuit in it, and an active circuit means a powered circuit. So passive DI, no power? Right, it's got what's called a transformer inside it. And I won't get into the electrical components, whatever, just think passive DI, no power, active DI, power. Okay, so how does it get its source of power? Well, three main choices. First, it could have a battery compartment, and so maybe a 9-volt battery or something plugs into it to give it power that way. Second choice, it could have phantom power. I'll explain that in a second. Third choice, it could have an external power supply, and I don't see this very often, but it could have one of those wall warts, plugs into an electrical outlet, transforms the voltage and sends it into the DI, powers it that way. Like I said, not very common. Usually it's phantom power, or less commonly a battery. Okay, so phantom power, what's that? Phantom power is when it's a source of power, source of voltage coming from a mixing console. And Think of the power requirements of most mixing boards, electrical devices, depending where you are in the world. So like North America, often 110, 120. Europe, often 220, 240. It depends where you are in the world. It can be usually one of those two, but it's different all over the place. So wherever you happen to be, your mixing console will take that higher level of power and it'll have some sort of step down transformer inside it that converts some of the voltage, sends it out. If you have phantom power turned on, if your mixer can supply phantom power, and if the switch is turned on to supply the phantom power, then it will send out a lower voltage electrical current along your balanced XLR cable, and that's going to power a remote device. Now, commonly 24 volt and 48 volt are the numbers I usually see for phantom power, but there could be different lower values. And things that get powered by phantom power, probably the most common thing is a condenser microphone. And there are different types of microphones. What's called a dynamic mic does not need phantom power. What's called a condenser microphone does need phantom power. So this one happens to be a condenser. And so if you don't have phantom power, then your mic is not going to send a signal. Okay, so it's that important. And I guess some microphones will have a battery compartment, but phantom power is more common. And so, yeah, that phantom power can power a microphone, it can power a DI box, it can power a couple other things. Okay, so that's how phantom power works. Anyway, how do you tell if your DI is an active or passive DI? That's an important question. And if you're lucky, it'll say so on it in big block letters. Active, passive, whatever. If it doesn't say, there are a couple ways that might give you an indication of which type it is. So think about active. Active needs power. So if there's any signs on your DI of power, then you can assume it's an active DI. So well, there's three. Is there a battery compartment? Well, if there's a battery compartment, then it's got power, which means it's not a passive DI. However, some DIs don't have battery compartments because they're only getting phantom power. So that can be tricky. And there might not be any indication that it's getting phantom power. Okay, what's your second choice? Is there a power switch? Power on-off switch. Okay, obviously if there's a power on-off switch, it's getting power somehow, so it's not a passive DI. But, again, some DIs do not have that switch. Some active DIs don't have that switch, because what happens is when you plug a 1/4-inch plug into the input thing, that's what turns it on. So instead of a physical switch on the side, the act of physically inserting the plug flips the switch inside. Okay? So power on-off switch, great indicator, not always there. And then your third choice, LED lights. If there's some sort of LED indicator that can light up, well, it needs power to light up. So if there's an LED, you know it's not a passive DI. Okay? So active DIs usually have at least a couple of those three indicators. Sometimes all three, but not often. Quite commonly, at least two of the three. A little more rarely, only one of the three. Very occasionally, you will get an active DI that does not have any of those three indicators. It won't have batteries, it won't have a power on-off switch, it won't have LEDs, yet it is still an active DI. In that case, hopefully it says so on the box, so you know. Very rare cases, it won't even say so, but whatever. Chances are, if it doesn't have those three, it's probably a passive DI unit. Okay, so the big question now is, when do you want to use an active DI and when do you want to use a passive DI? And basically, an active DI, the circuits can be designed to handle a much higher impedance level than a passive DI, so that's a good thing. However, with an active DI, it's easier to distort the signals. If you've got high input coming in, it's easier for that to be distorted. Passive DI, the higher input from a powered instrument is generally okay, it's easier. Okay, so I said that DIs are active and passive. Same thing can be said of instruments. And remember, active equals powered. So an active instrument is one that is powered. So an example, anything that plugs in, like electric piano, powered. Electric guitar, powered. Electric bass, powered. What about a guitar, an acoustic guitar with an electric acoustic connection, pickup? If it's got a battery in it, it's powered. It's an active instrument. Now, if it is the type of electric acoustic that does not take a battery, then it's a passive pickup. It's a passive instrument. So more often you'll see active instruments, I think. Yeah, okay, so that's the difference between active and passive instrument. Same thing, active and passive DIs. Power means active in either case. So when do you use which with which? Well, the simple way to remember is best case, opposites. Opposites attract. So if you've got an active instrument, you probably want to use a passive DI. If you've got a passive instrument, you probably want to use an active DI. And it's a little confusing, but I think the way to think of it is you don't want to have, between your DI and your instrument, you don't want to have a case where neither of them has power, and you don't want to have a case where both of them has power, because then it gets too strong. Okay? Now, having said that, those are best case scenarios. Active matched with passive, passive matched with active. You can, if you have to, use an active DI with an active instrument. Okay? Not the best case scenario, but what's the risk? Well, the biggest risk is that you're going to get a really strong signal. And so in extreme cases, that strong signal to certain boards, especially some Yamaha boards, I think, there's a chance of damaging the circuitry in your mixing console, in your mixing board. Okay? More frequently, a problem is the signal is so hot that you really have to turn down your gain on your channel. Okay? But you can do it. Just be careful. Put all your trim gain levels down really low when you're hooking up with an active DI and an active instrument, and bring them up very slowly and carefully. Okay? And then if you have passive DI with a passive instrument, what's the drawback? Well, you'll lose some quality. You'll probably lose some of the high frequencies in your instrument, and you're probably going to have more background noise. And that's simply because with the with no power on either side, you're going to have to turn your volumes up a little bit more, your levels up a little bit more, and as you bring those up, your background noise comes up with it. Okay? So not an ideal situation to use passive with passive, but it'll happen. Usually try to use opposites. Okay? Now some guitar amps have a DI built into them, and there's pros and cons to this. In my mind, maybe a few more pros. Well, I don't know. Disadvantages, okay? First disadvantage is a lot of times the DI output is after the amp's volume in the signal chain. And so what this means is once you've got it all hooked up, if your guitarist goes and fiddles with the volume, the signal level going off to your mixing board also changes with the volume. So, you know, you do your sound check before the show, and then the mixing board is set at a level where the guitar is at a perfect level. Sound engineer thinks everything's perfect, this is going to be great. Guitarist comes out on stage, cranks up the volume when the sound guy's not looking for a second, you know, someone's asking him a question, and then all of a sudden the signal going to his mixing board is way too hot. So that's a big risk of using an amp with a DI. Another thing, I've generally found quite often they're a little bit lower quality than a dedicated standalone DI. Also, an amp is less portable, you know, so if you only need a DI, you may not want to bring your entire amplifier to be used as the DI. You might want to take something a little bit more portable. Now, on a positive note, there are positive notes. First of all, it's convenient because it's a two-in-one solution. You may not have to buy a separate DI because you've already got one in your guitar amp. And because of that, it's probably more cost-effective. You know, why spend money on a DI if you've already got one in your amp? Okay? So pros and cons that you got to think about. Now, for the rest of the video, I guess what I've covered so far is all the theory that you need to know. And the stuff that you're about to see, I'm going to show you some footage of several DI boxes that I have, and we'll do a close-up look at the features. Now, this next stuff was actually filmed several weeks ago, before the stuff that you just watched, so I know there's going to be a little bit of overlap, some repetition, but that's probably good. It'll emphasize the concepts, and you'll be able to see in more detail how they actually apply on various models of DIs, okay? But if you're worried about whether or not you've seen you've learned all the theory behind them, yeah, at this point you have, okay? But let's take an examination right now of a bunch of sample DIs. Okay, so let's cover a few different DI boxes and show you roughly what they can look like. Here's an old one. It's called a Yorkville YDI-1P. So that stands for Yorkville Direct Injection -1, because it's mono, and P for passive. This one's kind of an old beat up one. You can see it's pretty rusty. A lot of the boxes that you buy nowadays, the better boxes, will be a little bit more resistant to rust. This one hasn't been outside as much, I guess. Still in rougher shape. And so you can see it's a passive box because it says so. Also, we have no battery input. We don't have any LEDs on it. That's a good indication. We have no lights. We have no power switch on off. So what do we have? Well, we have the ground switch on off. There's your ground lift. There is our XLR output to the mixer. On this side, we have the input, and you can tell it says from the instrument. And then this is our pass-through that could go out to an amplifier. One slight advantage of this box is that you can unscrew these quite easily to take the box apart, and it has normal screws on the outsides. Phillips screwdriver head. It's pretty easy to open. And not much else to say about this. This was a workhorse for people on a budget in Canada for many years, because Yorkville, Canadian company. Yeah, pretty decent, generic, low-end box. Now let's move over to this one. This one is, it's called the Art Accessories, and it's by Art. This one's called the Z Direct. They have another model called the X Direct, and the difference is that the Z is a passive and X is an active. Looking at this, there's our clue, passive. Says so right on the box. A lot of these do say whether they're active or passive on the box. So here's our input, and there's our pass-through if you want to send off to an amplifier. But our true output that we're looking for to go to the mixer for balancing or for impedance matching, whatever, there's our XLR output. And looking at the different settings on this one's interesting. It says attenuation. It has a -20 decibel there and another one there. And that is kind of odd. Why would it have the same thing twice? Is that a misprint? No, what it is it basically gives you a choice between 20 and 40 decibels of attenuation. So if you have one of them pressed in, it'll give you a 20 decibel attenuation. If you have both pressed in, you'll get a full 40. And these lights, they look like they should light up. And so that might throw you off at first and think, well, wait a sec, those are like LEDs. It's probably powered, it's probably an active DI. But no, they just happen to be clear plastic. They do not light up, and this is not a powered unit. Filter on this one, our low-cut filter. I had to look up the specs on this. This one is not a very strong low-cut filter. It's a 3 decibel attenuation at 30 hertz, so that's a pretty low frequency for the low-cut, and it's a pretty soft cut. And you'd have to look up the specs, because that's almost never written on a DI box what the attenuation would be on the low-cut filter. So I actually had to look that up on the internet to figure out what that was. Anyway, this one's a basic one. A lot of people seem to seem to enjoy using this one. I guess it's been a fairly popular model. I have nothing against it. It works. Now, our next one we're going to look at, this is a company called Radial Engineering. It's a Canadian company, and I'm pretty impressed with their products, and actually a lot of people are. It's a very sturdy unit. Like, this one weighs about half as much as this Radial Engineering unit, and it's got a good name. Like, there's a couple companies with really good names out there. Another example would be BSS. Their AR133 direct box is pretty popular. But here in Canada, this is a good choice for sure. Now these two are the same. This is called the Pro DI, or possibly the Pro D1. You'd think it would stand for DI, direct injection, but they do have another model called the D2, which leads me to wonder if maybe this is a D1. And I've never actually figured that out. Never bothered to look it up. But I suspect most people call it the DI, just because it's a DI box. And it's a passive direct box. And pretty solid construction. It normally has this rubber matting to keep it from sliding around so much on stage, and solid, heavy. It's got this nice enamel on it so it doesn't rust. And to get into it, you actually need a hex key. See, those are hex bolts holding it together, there and there. So you can get into it, a little trickier than just a conventional screwdriver. But you shouldn't need to get into it. There's no battery inside it or anything. So passive direct box, and of course input. You can tell here's our input, here's our pass through to an amplifier. But if you're going to the mixer, the signal goes straight through to your output, your XLR end. And this button over here, although it's not labeled on the side, which is one thing I don't like, this is your ground lift button. And it's actually labeled underneath this this label. That's how you know. On this side we have an attenuation, and this one, unlike the last one, is a 15 decibel attenuation, just a single attenuation, whereas the last one went either 20 or 40. But this is these are pretty rock solid units. I've always enjoyed them. Okay, so what else does Radial have? Now this is the D2. This is the one I was just mentioning, which makes me wonder if the other one's a D1. Same sort of rugged design, very heavy direct box. Not the sort of thing you want if you're carrying on a plane, but if you're on stage and whatnot, it's a good solid unit. Again, you need a hex key to get into it. And this one, why is it called a D2? Because it's stereo. Okay, so it's still a passive box, but it's a stereo passive. So you can see we have a left input and a right input. And if you're coming back out to your amp, we have a left through and a right through. And I suspect that we've lost our knobs on, see, look at that. Two of the fittings have come off and gotten lost, but that's okay. Some people don't even use the pass-through capability, so I guess it's not too important. And like the other one that we just looked at, 15 decibel attenuation, and you can do the two sides independently, left or right. Okay, and on the output side, here's our ground lift. Okay, and so there's our right channel and our left channel. So this would be handy for putting a piano in to that side, into these two, and then coming out with stereo from your piano, or possibly two acoustic guitars for some reason, coming out as two separate acoustic guitars. So kind of like a 2-in-1. And finally, let's look at one more box here. This one, again, Radial. You know, good name. May as well keep with what you know, what you trust. This one's called the J48. This one is an active direct box, and we know it's an active because it says so. What are our other clues? The battery. Oh, there's no battery on this one. You cannot open this case and put a battery in. And that's interesting because not a lot of active direct boxes do not have the capability of a battery. I wouldn't say this is a drawback of it, to be honest, because the battery compartment just means it has to take up more size. And I'm not a fan of using batteries during gigs because they can burn out. they can run out of energy. And so I always definitely prefer using phantom power. It gives you more consistency. You know it's not going to run out during the gig. And the interesting thing about this one is because there's no battery compartment, the phantom power, the way they've built this is a little bit stronger than it would be with a battery in terms of the electronics, which is nice because that actually, the way the electronics have been put together in this, it gives it a little bit more headroom. And so you're less likely to have to deal with distortion. If you have to put this active box on an active instrument, you're a little bit less likely to have problems with having to really attenuate the signal than you would if you were using a different active box, most other active boxes that use batteries. So that's one slight advantage of this particular model. Now, there's no on-off switch, so that's a second clue that you would normally have to know that it's an active box. So are we positive it's active other than the writing? Well, we do have one LED light here, and I will take this to a mixer in a second and plug in phantom power, and we'll see if the light comes on, okay? So anyway, trust me, it is active. The light will come on. And so our settings on this, input, so your input comes in here. Remember that this one is a mono, not a stereo box like the last one. Your input comes in through here. It can pass back out through to another amplifier, to an amplifier. It's not coming from an amplifier. And on this end, we have the XLR output to the mixer. We have a couple settings here. Here's our phase shift button, reverse 180. Here's our low cut filter. And if I remember correctly, I believe that the low cut on this one is 6 decibels at 80 hertz. So definitely a lot stronger than the Z Direct box that we looked at a minute ago. There's your ground lift setting. And on this side, we have 15 decibel attenuation, just like the other radial boxes that we showed a minute ago. Now here's something I haven't talked about before, merge. This is not something you see on very many DI boxes at all. Very specific to this model. This one's neat because if you have stereo coming in, 2 separate mono, like a left and right from a piano, even though this is not supposed to be an input, and on most DI boxes it's not an input, on this particular one, if you plug the left and right mono signals from, say, a piano into this, it actually will take them through and combine them into a stereo signal there, into a split mono, into a combined mono signal there. And it does it only if you press this merge button. So you have to have that in. And it's neat because it actually combines them resistively. So it combines them properly instead of just sending 2 parallel signals. Okay, so yeah, so that's kind of interesting. It's a feature I've never actually used, but apparently it works. And also, I should point out that the I thought I had something else I was going to say about this. No, I can't think of what it was. On this thing, this is what I was thinking about, because this is a stereo one. It's kind of odd when you look at this, that your left is on the right side and the right is on the left side. That seems very unconventional. But remember, it's just because we have left and right here. And so the input, when you're plugging in, left and right makes sense. But of course, they're not going to cross the circuitry in here quite often because it's awkward. It'd be nice if that was on the left and this was on the right, but because the circuitry is basically going straight through, that's why it doesn't cross over. But I guess what I was trying to think of with this is that this kind of can take a stereo input and give you a single feed. I know what I was going to say. Is the other reason you might use this is if, for instance, you're taking 2 Okay, so why would you put the why would you take an electric piano and put the left and right into here together when most electric pianos have the forced mono side if you use just the left side? It doesn't really make sense. I mean, there's probably pianos out there that cannot combine to mono in the piano. So in that case, this would overcome that problem. But what if you were using two separate guitars, two acoustic guitars on a stage? For some reason, you didn't want to buy two separate DI boxes. Perhaps you only had a very limited number of input channels left on your mixer. Maybe you're using just a tiny mixer that's got, say 4 channels, or even 2 channels, who knows. So maybe the mic is going into one channel. Maybe you've got an MC that is using one of your 4 channels. You've got 2 performers on stage, and they're using microphones for channels 2 and 3, and you've got 2 guitars, so you've got 5 things that you want to feed into your board, but you've got a 4-channel board. Well, by combining the 2 guitars through this, you can merge that signal, and they'll both come through one channel on the mixer. I mean, that's not an ideal situation, and that's kind of that's kind of a rare situation. I had to think to come up with a example of why that would be useful, but it's kind of neat that it has it. Anyway, again, radial engineering. This one's called the J48, and a very nice active. If you're going to get an active box, this is definitely one of the best. Okay, so there you have it. Now, if I was to give a quick 60-second recap of everything, point 1, DI box used to convert an unbalanced 1/4-inch signal to a balanced XLR signal that can be sent for long distances without significant signal degradation. Point 2, direct box also can be used for eliminating ground hum. Point 3, know the difference between active and passive DIs, active and passive instruments. Active is powered in both cases. And finally, point 4, any DI will work with any instrument, but for the best results, pair an active with a passive. Okay, that's all there is to it. So if you want to see more models, check out a website online like, say, sweetwater.com. If you're in Canada, check out the Long and McQuaid website, or go into one of their local stores and see what they have to offer. Thanks for watching. Thanks for sharing. Thanks for subscribing. And thanks for commenting. If you happen to be a SoundCloud user or a Twitter user, would love it if you would follow me on either of those 2 services. Share this video anywhere at all. If you know other people that might benefit from it, please share it. And finally, like I said, I've got tons of other videos, gear reviews, stuff about audio recording, music production, DJing, etc., etc. Full organized list of all my videos that you can bookmark at djbolivia.ca/videos. Okay? Have a good day.